Hey guys, here are notes for section 9.6 called loci. That's the plural. Locus is the other non-plural word, but let me explain what a loci is. And you can just fill in the blanks and pause it if you need to. A locus or loci of points is a collection or cluster. So if you throw a bunch of points, all of them that satisfy a certain given condition. So it's a locus or loci of points. It's a collection or cluster of points that satisfy a given condition. To find the locus, draw or describe the points that satisfy the condition. So for example, here's what this probably doesn't even make sense to you guys. It'll make sense as soon as you see what the examples are down here. It says find the locus of all points that are 3 units from point C. So here's point C. Let's say I took a ruler and I measured 3 units in all different directions. I kept measuring 3 units away from point C. Here's what that would look like. All those dots, they'd all be 3 units away from point C. So the locus would be called a circle because that's the collection of points. Every single one of these points is 3 units away from point C. So it's a collection of points that describes a condition. So it's describing 3 units away, so it's a collection that would describe points that are 3 units away. That means it would have to be a circle, would be the locus. Here are some common loci in a plane. You've probably seen the one already. A circle, that's a common one. Those are all equidistant from a given point. You'd call that locus a circle. And then a line would be another one. It's the locus of all points that are equidistant from a given line or a plane, and it's going to be parallel to that line or plane. So you might have a circle, or you might have a line. It would be just a common loci in a plane. You could also have an arc, which would be part of a circle. So it might be all units that are 3 units away, or all points that are 3 units away in a given arc or whatever. So you could have an arc. Those would be common loci in a plane. Now, a common loci in space would be a sphere. Those would be locus of points in space, not just coplanar, not just on a plane, but in space that are equidistant from a point. So that could be a sphere, like a ball, like if you put a point in the center of a basketball, and then all the points that are so many units away from it would be a sphere. The basketball itself would be the locus. A cylinder would be all the locus of points in space equidistant to a given line. So it would be a sphere. And you can pause the video if you need to. Okay, so here's just a couple of quick examples. Find the locus of points that are equidistant from point A and B. So I want to find every single dot that I can that could fit on here that is the same distance from A as it is from B. So here's just a few of the dots. So these dots are all the same distance from A as they are to B, and your locus would be a line. That line would be the same distance away from those 2 dots. So that would be the locus itself would be a line. Find the locus of points that are 1 inch from K. So I want to know where all the points are that are 1 inch away from K. Well, you could have 1 inches above, you could have 1 inches below. So this locus of points would actually be 2 parallel lines to K. So the locus of points that are all 1 inch away from K would be a parallel line on top and a parallel line on the bottom. Find the locus of points that are no more than 3 units from point C. No more than means it cannot be bigger than, less than 3 units from point C. So the dots, these are all the ones that are 3 units away from C. The locus would be the inside part, not the outside part. It would be any dot inside here. So this locus would actually be a filled-in circle. It would be a solid circle with point C as the center. Find the locus of points that are at most 2 centimeters from line M. So 2 centimeters above, 2 centimeters below, and they can't be more than it. It has at most 2 centimeters. So the dots would be here, 2 centimeters above, 2 centimeters below. But the locus itself would be this rectangular box between these two. Any point in here would be at no more than 2 centimeters from line M. So it would actually be a rectangle, that one would be. And I think that's it. Don't forget about your practice problems. This was a really short section. So this is just a description for each one of these. And then just a couple of mixed review ones. See if you can remember those from previous sections. And we'll see you guys later.